Hello everybody and welcome to our second science lesson. In this lesson we're still thinking about materials, but today we're learning a little bit about their properties. When we describe a material, we're describing what's special about that material, what it looks like and how it behaves. It's a little bit like in English when we read a story and we describe a character. Have a little listen to this.
Simple science. What are materials? Everything around us is made of materials. For example, this knife is made of metal. This ruler is made of plastic. This spoon is made of wood. This napkin is made of paper. This window is made of glass. This brick is made of clay. These steps are made of rock. This tire is made of rubber. And this towel is made of fabric. Metal, plastic, wood, paper, glass, clay, rock, rubber, and fabric are some of the common materials everyday objects around us are made of. Materials have different properties. For example, the metal this knife is made of is shiny and smooth. But the baked clay this brick is made of is dull and rough. The wood this spoon is made of is rigid. But the plastic this ruler is made of is bendy. The glass this window is made of is transparent. But the rubber this tire is made of is opaque. The rock these steps are made of is hard. But the fabric this towel is made of is soft. Shiny or dull, smooth or rough, rigid or bendy, transparent or opaque, and hard or soft are some of the properties different materials can have. The properties of a material make it more useful for some purposes than others. For example, a window is designed to let the light in and to keep the rain out. So we want to choose a material that is both transparent and waterproof when making a window. Glass is transparent and waterproof, so it is a useful material for making windows out of. What property of granite rock makes it useful for making steps? Granite rock is hard. What properties of leather make it useful for making shoes and belts? Leather is flexible and strong. You can test the properties of a range of materials to see which is best suited for a particular purpose. For example, in designing an umbrella, you want to choose a material that is waterproof. So you could test a range of materials such as paper, fabric, and plastic to see how waterproof they are by stretching them over a container and dropping water on them and measuring how much water they let through.
Okay, that's given me a great idea, and maybe you can remember this picture here with this little experiment going on for the next part of our lesson. Can you remember Traction Man? Well, here he is again with Scrubbing Brush, his lovely dog, and he says, "I'm going diving in the sink again." And in today's lesson, we're going to help Traction Man. Let's have a little look. Traction Man is ready for anything. But what's this? Traction Man needs a new waterproof diving outfit. Can you help him find the right material? So our big question today is this. Which materials are waterproof? So you're going to talk to your adult at home and you're going to try and think of at least 3 different materials that you think of that you think might be waterproof. Okay, here's some materials that you might use in today's experiment. We're going to do a little test. So I want you to think of some materials in your house that you could get together, and we're going to test which of them are waterproof. That means they don't let any of the drops of water absorb into them. Right, let's have a little look at the next slide. Traction Man's wondering, how can we test which materials are waterproof? And what will we need? Well, you're going to need the materials, aren't you? You're going to need some water. You'll also need a tray, or maybe you can do your experiment at the kitchen sink. And this measuring jug, if you have one at home, that will be very useful. We'll talk about that a little bit later. So I want you to draw and label a picture of what you're going to do to work out what material or materials are waterproof. Pause the video now and draw your teacher a picture with labels of what that experiment might look like. Okay, I wonder what your drawing looks like. Maybe you've drawn some materials with some water being dropped onto them. Maybe you've thought about making it a fair test and using the same amount of water in a spoon. Or maybe if you've got a little bottle. Maybe your drawing looks like this. Maybe you're thinking of putting some different materials over the top of containers. And again, using a spoon to measure out some water and pop it on the top of each of the materials to observe and watch carefully what happens and see if the material looks a little bit wet or if any of the water drops through, because then it would not be waterproof. Maybe your drawing looks a bit like from the little video we've just seen. Maybe you've done some labels, paper, fabric, plastic. You might have tin foil or another material. Okay. Well done, everyone. So now it's nearly time to start your experiment. But remember, try to make it a fair test. Traction Man's asking, what will we need to keep the same? Well, the materials are going to be different, aren't they? They won't be the same. But the amount of water that you drop onto each material should be the same. Then this experiment is a fair test. Have a think about which material you think will be waterproof and which do you think will be non-waterproof. That means not waterproof. And see if you can fill in and continue these sentence starters. I think will be waterproof because. I think will not be waterproof because. Okay, and then when you've finished your experiment, can you record, can you make a note of what's happened in your experiment? This is an example here. So the materials are listed down this side: tissue, a plastic bag, some kitchen roll, some cardboard, some fabric. And then on this side, the person's going to give a tick if it is waterproof. So if it doesn't let water in, they're going to get a tick. But they're going to get a cross if it is not waterproof. Maybe for some of our older children, maybe you could do a chart a little bit like this. Traction man saying, complete the chart to show your results. So maybe you can list your materials in one column, and perhaps you could have 3 extra columns, whether it's absorbent, whether the water soaks in, that's not waterproof, whether it drips through a little bit, that's non-waterproof, or whether if the water stays on top of the material, yay, that means it's waterproof, so you could give it a tick. Look, I've done 1 at home for tin foil. The tin foil didn't soak in any water. It didn't drip through the tin foil. It just sat on the top. But I haven't finished my experiment yet. Okay, it's over to you. Get thinking, get testing, and don't forget to make a note or a chart of your results and send them to your teacher. All for now. Bye.